Alright folks, this example is a little trickier because you have three terms as opposed to what we had before. So the other techniques we learned aren't really applicable because you can look at these three numbers, you can see that between x, 4x, and 3, but there's not like there's a common variable like x in all three of them, and it's not like there's a common number in front that you can factor out. So it's going to take a little bit more work. One way that you can kind of attack or approach this problem is by using algebra tiles or by using a chart. And so I'll just show the algebra tiles just to start because it's one way that's done. So if I had this expression right here, the first thing I'll do is I'll draw my x squared. So there's my x squared tile. Next thing I'll do is now I'll draw my 4x's, and this takes a little bit of trial and error. I'll just draw, or I'll show an error example. So 2, 3. I have to draw a perfect rectangle. So what ends up happening here is you can kind of go 1, 2, 3, and you go, oh no, that didn't work. So I know that one didn't work. So the next one you can try. Maybe I'll do 1 there. Do 1 there, and I'll go 1 there. Oops, and there, and look, my 3 1s fit nicely right there. And you know you've done this right when you make a nice rectangle. So when this is a nice rectangle, you know that you've kind of got the solution correct. So the next thing you're going to do is then you measure the lengths of your sides. So I look at how long that side right there is, and that's the length of x, and that's the length of 1. And then again, this is the length of x, and this is the length of 1, 2, 3. So, and there are my two factors. So that involves a bit of trial and error, but that's one method you can do. Another method that we can do is you first start by drawing a t-chart. This column of the t-chart is adding, and this column of the t-chart is multiplying. So what you got to do, why did I write 4? Sorry about that. So that's multiplying. So what you got to do is you got to look at your expression, and what you have right here with x gets written on this side, so you would write plus 4 there, and what you have right here that is all by itself, the term that has no x value, you write right there. So now what you have to do in this column is, in this column you have to think of everything that, all the different factors of 3, or all the different ways you can multiply to make 3. So in my head, I also look at the sign in front of 3, and I see that it's a positive 3 and a positive 4. So I know that a positive times a positive makes a positive, or a negative times a negative makes a positive. And because I can see this term right here is a positive, I can assume that my two factors are both positive. So write a plus and a plus to represent my two factors. So I can think of all the different ways I can multiply to get 3 with whole numbers, and I can only think of multiplying to get 3 with whole numbers with 1 and 3. So if I multiply 1 times 3, I get 3. And if I add 1 plus 3, I get 4. So because of this, I know that those are my two factors of this expression, and then I fix it up or finish it off. I know that this is a positive, this is a positive, and then I write out my answer. X plus 1 is one of my factors, and x plus 3 is my other factor. So then I would finish that off by saying x plus 1 in brackets, x plus 3. And there we go, that's factored. And you would just stop right there with those two sets of brackets, and that would be done. So in this one, again, I could solve it using Algebra Tiles, and it would take me a little bit more time. But you could definitely do it. And I'll try to take a second, and I'll try to role model that. So there's my x squared piece, and this might take a bit of trial and error because I'm actually going to kind of trial and error at it. So now I know I've got 6 negatives. So I'm going to draw my negative tiles as blue. So there's 1, 2, 3, 4, 5, I think I got it, 6. There's all my negative x pieces. Okay, so there's all my negative x pieces, and then I know I have 8 positives. And I kind of just guessed at where I should arrange them. And I visualized a bit, but there's my expression represented with algebra tiles, factored properly because it forms a rectangle. And I measure the lengths of my sides. That's x in length, and there's 2 negative pieces, so I'd say minus 2. That's x in length, and that's minus 4 in length. So that would give me x minus 2, x minus 4. If that method doesn't work for you, the first thing I would do is I would start with my plus times table. I would again look at my expression and see that I need to add to negative 6. I need to multiply to positive 8. So when I see that I've got to add to a negative but multiply to a positive, that's a situation where you're going to have to assume that, or you're going to have to know, not assume, you're going to have to know that this is a time where you're going to have to take a negative and multiply it by a negative. So our two numbers are going to be negatives, and so they'll make a positive. So now I list all the factors of 8. We've got 1 and 8, 2 and 4, and I can't think of many others. So the next thing I do is what's 1 minus 8, and that's negative 9. And what's negative 1 minus negative 8, and that's negative 9. And then I think about what's negative 2 minus negative 4, and that makes negative 6. So right here, those are my numerical factors. So I then write out x minus 2 and x minus 4 are my factors of that. So then I can drop down my equal sign. I go bracket x minus 2, close bracket, x minus 4. And there we go. Alright, this one's a little trickier, and I'll try my best to explain it. So now you have a negative, and you're multiplying to make a negative. So I hope that when you see that you're multiplying to a negative, you know that what's going to end up happening is you're going to have a positive number and a negative number, because a positive times a negative makes a negative. The next thing you have to think of is you have to look at what you're adding to. So we're adding to negative 3 and multiplying to negative 10. When you look at what you're adding to, the value here that it's a negative 3 tells us that in our two numbers that we're going to be brainstorming, one of the two numbers is going to be bigger than the other. And because it's a negative number, I know that this negative is going to be our big number. Yikes. So now I have to think of all the things to multiply to make negative 10. Well, I could say it's 1 and 10. You see I wrote 10 in the big number column, and I could think of 2 and 5. So now we take a second and do some adding, because I can't think of any other whole numbers to multiply to make negative 10. So positive 1 and negative 10. What's what's positive 1 minus 10? And that's negative 9. And what's positive 2 minus 5? Hey, look at that. this makes -3 when you add it together. So those are our two terms. So I'd write x plus 2 and x minus 5. And then I'd finish it up over here with x minus 2 and, x plus 2 and x minus 5. So in this example, I'm going to start out with my chart. Oops, that's not a fancy x, that's a multiply. Sorry about that. I know I've got to add to positive 2 and multiply to negative 24. Again, this time I've got to do some thinking because I've got to see that I'm multiplying to make a negative. So that means that my two factors, one of them is going to be positive and one of them is going to be negative because a positive times a negative makes a negative. And then the next thing I'm going to do is I need to look at this term right here and see that it's positive. So I know that my big number is going to be positive. Hey kiddo. So now I have to list all my terms. So what multiplies to make 24? Just wait, kiddo. So I know that I can have 24 and 1. I can have 12 and 2. I can have 8 and 3. And I can have 6 and 4. So now I write in my integer values. And then I take a second and I start to do some thinking. So, what's positive 24 minus 1? Nope. What's 12 minus 2? That's 10. What's positive 8 minus 3? That's 5. What's positive 6 minus 4? Hey, look at that. That makes positive 2. So then I know my factors of this are x plus, yikes, that's a messy plus. There we go. X plus 6. X minus 4. Want to say goodbye, Stella? Say goodbye.
Goodbye.